Okay, Salaam alaikum and good morning. I see Rasha, Zainab, Abdulreza, Abdullah, Ali, Sadiq, Ali, Muzaffar, Emad, Farah, Mohje, if Mohje is correct, Mohje. Distribution network. Today I explain load characteristics in electrical distribution networks. Are you ready for start our lecture? Okay. Please put a message for other students in WhatsApp group for connecting the lecture and coming to course and starting our course. Okay, Arisade, I will allow for you for downloading the lecture. Okay, Arisader, you can download a slide from here. No problem. Okay, thank you for your coming and good morning, ladies and gentlemen. And I want to continue our course in load characteristics in distribution networks. First, I explain in English language, and then I translate some points in Farsi language for you. Okay, no problem. In bulk power systems, for power systems in high voltage and in sub-transmission and extra high voltage network, for load flow calculation, for stability studies, it is examined how much active and reactive power is present in a given bus or what its load curve is. Okay, for example, for voltage stability, we need ZIP model for load. But in distribution networks, loads can be separated and explained with many characteristics for definition of this load. For example, residential, commercial, and other load, and many characteristics for these loads. Okay, I explain again these sentences here. In power systems, load in almost cases we defined only with P and Q. For example, for load flow calculation in extra high voltage and others, we need P, for example, for a buses in Basra, we can write P equal 200 megawatt, and we can write to that bus Q is 100 megawatt and others. Okay, for definition, please see, for definition of the load in power system, studies such as load flow, power system stability, short circuit, and others, only you use P and Q in many cases, and in some special cases, for you use ZIB model, impedance, current, and power model for description of the load in buses in power system studies, okay? But in distribution network, we need to explain a load by many characteristics. In this chapter of the lecture, I want to introduce characteristics for definition of load in distribution network studies. Okay? Do you have any comment or question about purpose of this lecture today? No? The applications for load characteristics definition in distribution networks is electrical load forecasting or estimation in a small area, substation, feeders in distribution networks, capacity determination of equipment in planning stage in distribution networks, electric distribution network operations, and also for designing demand response programs, and also for market operation in distribution side, such as local market, retail market, and others. In this chapter, some of the load characteristics are explained for you. I start with the types of consumer or customer in distribution networks. We have in Iran and many countries some class for types of distribution network load. For example, residential for homes. Okay, I think you call in Arabic language home is Beit, yes? Am I correct? The residential load. And the industrial we can write in Farsi language San'at. Sanat. I don't know what is the industrial translation in Arabic language. Industrial. We write in Sanat. The load of residential, load of Sanai. In residential, in industrial or Sanai or Sanat load, commercial and utilities such as shopping center and others. Okay. In Tejari, in Farah, right, for us, commercial and agricultural in Farsi is Keshavarzi, right here. Keshavarzi. I think you in Arabic what? In Example, load is residential or load is industrial or others. It is characteristic of the load, one of the characteristics of the load, okay? Other characteristic is demand. Okay, in Farsi, we write demand by these words, or write in Farsi demand, or write taqaza. Okay. If you know in language, please write me demand. Okay. I explain about demand. The demand of an installation or system is the load at the receiving terminals average over a specified interval of time. Here, the load may be given in kilowatts, kilowatts, kilowatt amperes, kilovolt amperes, or amperes. Okay. Okay. It is important definition. I want to define this demand interval and come back to demand again. Demand interval is the period over which the load is averaged. This, Alisa, other students, do you receiving my voice clear? My voice is clear? Okay, okay. Please, please, Alisa, refresh your screen again and hope fix the problem. Okay. Demand interval, it is period over which the load is average. The selected delta T period may be 15, 13, 30, 1 hour, or even longer. Of course, there may be situation where 15 and 30 minute demands are identical. Okay. I explain this again. Please see. I explain this again. Oh, for example, please see. Consider a industrial load, for example, in city in Iraq, in Basra. This is the load, industrial load in Basra, okay? I cannot write easily. Please consider this is the industrial load in one city, for example, in Basra, okay? The utility wants for us for determining the demand of this load. The demand of this load. Okay, please see. If you connect a device such as data logger, I write here, data data logger. Data logger is a device for measuring the demand, the load of this industrial factory. You have, please see, okay, Mr. Ali, measuring and recording. For example, you measuring and recorded the load. Here is the, for example, watt or ampere or other, no problem. For example, ampere, it is easy for understanding. You have, for example, 7 o'clock morning, the factory is closed, we have a low load, and in 8 o'clock, start our motors, we have inrush current here, and then try it easily by mouse. You have inrush current in the motors, and come back again to normal situation. For example, is the 12 o'clock. The employees are going to lunch, and again in afternoon we again start the motors and inrush of the current, and then in, for example, 4 p.m. the factory is closed and the load reached to minimum. Okay, Alisada, it is, for example, measuring and recording by data logger of the current of the factory. Any comments? Please see. You have here, for example, this measuring data is the 100 ampere, for example, 100 ampere. This is the 90 ampere, okay? But the average, you see, but the average amperes in the factory maximum reach to 50. Okay, Alisada, Farah, please see. Okay, Alisada, we need 100 ampere or 9 ampere for a small time. For example, in 5 minutes, in 10 minutes only. But the maximum load in average time reach to 15. Okay, I have a question. What is the demand of the factory? What is demand of the factory? You can maybe answer to me 100, the maximum demand of the factory, okay? But as Ali Sadr wrote us, 100 amperes duration only for a small time. For example, in 10 minutes or in 20 minutes and others, okay? The factory need to buy the demand from utility, from electrical distribution of Basra, 100 meter as demand, but 100 meter duration is only for 10 minutes, for 5 minutes, okay? No problem. Here, for some reasons, in some reasons, need for averaging, please see the averaging of the load curve. For example, if select demand interval 30 minutes, you need average this curve by 30 minutes interval. Please see the average is converted here, 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 and others. We average the load curve in 30 minutes, okay? The blue color, please see, the blue color is the demand curve. Demand curve, okay? Right here, demand curve. Demand curve with demand interval equal 30 minutes. 30 minutes. Okay. I averaged, you see, I averaged a load curve is this curve, in 30 minutes interval. If you see, the inrush current is omitted in demand interval by selecting demand interval is 30 and in the demand curve. Demand curve is smoother. Load curve, okay. In countries, the utilities, for example, the energy department and ministry in countries select demand interval and the load curves averaged by this demand interval, and the demand interval is base for buying the power or current from utilities. Okay, the factory, please see, the factory need only buy energy from utility of Basra by blue color curve, not the red color curve. Okay, for example, this factory need this maximum. This maximum may be reached to 70, not 100, and maybe owner of the factory need a reserve, and for example buy 80 ampere or 80,000 kilowatt from the utility. Okay, this curve, this red curve is the load curve, measured and recorded by the data logger, and the blue curve is the averaged curve in demand intervals. For example, here 30 minutes. Okay, this blue color curve is called demand curve. Okay, you have any comment? Do you understand? Do you understand the concept of demand curve? Okay. The maximum demand of an installation or system is the greatest of all demand which have occurred during the specified time. This blue color is demand curve, and the maximum amount of this demand curve is the maximum demand. Okay? In this here we defined the load curve. Load curve is measured and recorded by data logger with a specific sampling rate, and it is recording the inrush current and many spike in the load. This is the load. Okay. You select demand interval. Demand interval is selected by regulator in or energy ministries in countries. For example, in Iran we have 30 minutes. If you average this curve in 30 minutes, you can reach is smoother. For example, okay, this is the demand curve. This is the maximum demand. Okay, but this is the maximum load. Do you have any comment? Do you understand? Any question? Mr. Karrar, Mr. Murtaza, Ms. Farah, Ahmad, Ali, you have any, Zainab, you have any comment? No problem? Okay. Next slide. We are waiting for next slide. The speed of the internet is low. This is the Farsi language. I switch to others. Okay, in our building is an alarm. No, I hope no. Mr. Farah, I hope no. Please wait for a moment. Okay, I disconnect. Okay, load curve is illustrating the variation in electrical load over a specific time, for example, for daily, for monthly, for weekly. Okay. For example, here, the demand or load curve in 24 hours, it is the daily load curve. Okay, no problem. We have three characteristics in load curve. Base load is the minimum load in all time. For example, in 24 hours, minimum load is 5 kilowatt. This is the base load. Okay. We have average load. Average load is the average of the load in 24 hours. Okay. And the maximum load. In load curve, we have base load, average load, and maximum load. Okay, you have any question? Also, please see, we have other curve. It's called load duration curve. Load duration curve is the plot of load versus time duration for which that load was persisting. You know what is load duration curve? You need to explain the load duration curve, Mr. Ahmad Karrar Farah. No? Okay. Okay, I explain for load duration curve for you. Please see. Need a free space. For example, please moment. I want to free space for presenting an example for load duration curve. Please moment. Okay, I need a space for presenting the concept of load duration curve. Please see. For example, it is very simple, but listen carefully. For example, I want to draw the load duration curve for this load. For example, we have a load here. We measured the load hour to hour. We have a vector with 24. Please see 24 number. For example, in hour 1, hour 2, hour 3, and hour 24, okay, in one day. For example, this is the ampere. For example, this one is the 10. In hour 2 is 10 again. This 3 is 9. Is, for example, is the 9, and until to 7 reach to 10 again. For example, in 8 is 12, and others. Okay. For example, in peak load, for example, I write continue here. For example, in 14 hour to 16 hour, the weather is hot and load is reached to 20, 20, this is 15, and 12. Okay, and decrease to other. Do you understand? This is the load hour by hour in current for load. No problem. For example, 1 hour 10, 2 hour 10, 3, 9, 9, 10, 12, and other, and the peak is 20, and for example, then reach to 21 in night and 22 in night. This reach to 25 ampere and 25 ampere. Okay? Do you understand? If you draw this curve by this here, for example, hour 1, hour 2, hour 3, and hour 24, here is ampere. The load will be for example 10 here, in here 10, in here 9, for example in here 9, and in 7 is 10, and then in 8, for example 12, and for example in 21 is 25, and others. If you connect this point together, you reach the load curve. No problem. It's okay. You can write this in Excel, in Access, in Office, and you draw this load curve. Okay. These are recorded by data logger. No problem. The problem wants us for drawing the load duration curve. This is the load curve, not load duration curve. We want draw the load duration curve. Please see. I clean here. For load duration curve, first I change the color. For load duration curve, first you need the sorting this vector from highest number to lowest number. For example, if you sorting this, you have 25, 25. This is the highest. 25, 25, and for example, 21, 21, 21, and reach to 20, 20, and if you continue, reach to lowest, 9, 9. These have 24 numbers. Okay. This vector is sorting type of this vector from highest number to lowest number. Okay, Carol. Okay, Zainab, no problem. In second stage, please see. In second stage, you write a vector. See? Vector with two columns. Please see. You write 25. See here, 25. In here, we write 24 is about 2 hours from 24 hours. We write 2 hours from 24 hours. The duration of 24 ampere is only 2 hours from 24 hours. 24 hours all of the days, but 2 hours we 2 hours, Arisa, the 2 hours is the hours 1 and hours 2. Only we see 24 hours only in 2 hours. No, Arisa, the highest, this is the highest value. The highest value is 25. Duration is only for 2 hours. Okay, please see here. Please see. 20. It is important. 21 ampere and highest. 21 ampere and higher. 21 ampere and higher. Duration is 5 hours from 24 hours. Yes, Murtaza. We start from highest. Okay. Yes, please see. We 21 and 21 and 25 year. We have 5 hour, 21 and 20 and higher 21 hours. We 5 hours, 21 and higher. And for example, the third 20 from highest number to lowest, please see. 20 ampere and higher. We see 1, 2, 3, 4, 5, 7. Right, 7 from 24. Okay. If you continue, the lowest number is 9. I ask you, what is duration? What is duration of 9 and higher number of 9? Higher number of 9 is 20, 21, 20. 9 is 20. Yes, Murtaza. 24 in 24 hours. Okay. We have a small area here, but no problem. If you draw this number against these numbers, you can reach to low duration. For example, see here. We have 25. Here is the duration. This is the 25. Here is the 224. Okay. 1 point. and then 21. 21 in 5. 24. And finally 9 is 24 to 24, okay? You connect these points. This curve is load duration curve. Okay? Okay? Do you need any other example? Abdullah, Abdurreza, Zainab, Rana, you need other example? Okay. Yes. Go to this slide. The free space. Okay. Example. I write for you other example. Okay. I write you for a day load in a factory, for example, in 1 hour to 20 hour, 24 hour. For example, in here load of a residential substation. Substation in, for example, in Najaf. Okay, here is 10 ampere 2, 3, 4, 5, 6, 7, 8, 9. For example, 10, 10, 10, 10, 6 is 12, 14. The weather in Iran is very hot. I think Iraq is also, yes. 12, 14. For example, in 8 is the 16. 9 is 16. And continue. 10, 11, 12, 13. Please write these vectors. I need 14, 15, 16, 9, 17. For example, reach to 16, 17, 12, 20, 23, 25, 25, 25, and we reach to 18, 19, 20 hour, 21 hour, 22, 23, and 24. For example, 23, 23, 30, 30, 28, 28, 12. Okay. Okay. Any student? Any comment? This is the vector of 24 hours for residential load in a typical residential substation in, for example, Najaf City. 10, 10, 10, and other, we have 24 number here. No problems. We want write the vector for load distribution curve. Okay, I start and I want you continue in your home as homework. Let's see. I write here. You need first the you have my voice. You need, please see, you need to write these numbers by highest number to lowest numbers. For example, you write the highest number is 30, 30, 30, and then 28, 28, and then 25. Okay, you need sorting these numbers. Please in your home as homework. Please sort these numbers by, for example, Excel. Do you able to work with Excel? Excel? Okay. Mr. Ahmad, first you sorting these numbers from highest to lowest, okay? And then you write other vector from highest, for example, 30. You can write duration, for example, here 2 from 24, and then, for example, 28 and above. 28 and above is the 228 and 213 for 24. Okay. You write this vector and in Excel, please draw this ampere against this duration. You can reach the low duration curve for this example. No problem. I want you please solve this example in Excel and send me in WhatsApp group your answers. Okay? No problem. I come back to our main slide. For example, this figure shows the various load curve. Please see, this is the residential in 24. You can see the lowest in morning, in early morning, and then rising, and for example 20 here is the highest. Okay, in industrial load, here in industrial load, this is the lowest, and the it's increasing to these numbers, and then, and for example in red blue is office. This is the 0, and reach to highest, it is constant, and decreasing to low, it is the office. For example, governmental office. For example, in large user is here, and others. Okay. One of the useful information in distribution network is the typical load curve in a city. For example, if you're living in Baghdad, you can reach to typical load curve for residential substation, for commercial substation, for agricultural substation, and others. It is typical load curve with various loads such as residential, industrial, commercial, large user, agricultural, governmental, and office. Okay. For example, for your information, in Iran, I back to free space. For example, in Iran, please see the annually load of in Iran is for example, I write for 24 hours in summer. The load of Iran is, if you let me take this year, the 12. It is the 12 p.m. the next day. Okay. It is approximately 30 megawatts. For Iran is 30,000 megawatts, or 30, I write here easily, 30,000 megawatts. This is decreased very, very small in 4 a.m. reach to 28. In for example, 30 or 1 p.m. Yesterday reached to to very high amount, 60,000 megawatts, and then decrease afternoon, and in night reach to 57,000 megawatts. And then, for example, this is the curve of the Iran overall electricity consumption yesterday. In 1 o'clock afternoon, we reached to 60,000 megawatts. It is very, very high demand. And in night, reached to 57 megawatts. In Iran, the peak of the load in summer is the peak in afternoon. Okay, the peak of afternoon is greater than peak of the night in the Iran, because the industrial factories active here. At night only we have almost residential loads. Okay. For example, here, typical load for residential, for small commercial, for medium commercial, and large commercial are shown in the figures. This is the residential peak days. This is the average residential load. This is the average small commercial. This is the peak of small commercial and others. Do you need any break for 5 minutes or 10 minutes for drinking a tea or coffee and come back to, okay, Mr. Carrer and other students, please go for drinking a coffee or tea and come back after 10 minutes to course, okay? Thank you for your attendance and considerations.
يسوي الإقامة يبكي على سن يقول لي لسان الفتاة أخرس يقول على السن يضرب يوصل 3 سنين يصير أخرس سبحان الله. هذا شو بيعطيش بيا ولا حسب
Okay, are you ready for continue our course? Okay. I hope to drink a coffee and ready for other characteristics. Thank you. Thank you, Carol. Thank you, Rena. The other example, please see. Assume that the loading data given in table 1, in this table 1, belongs to one of the primary feeders of NL and the NLP company, and that there are for a typical winter day. Developed the daily load curve for this primary feeder. Is the in Arabic language, I think, light of Ma'aber, yeah, light. What is Nur? Light of street lighting. What is the Arabic translation? I think street in Arabic is the Ma'aber, yeah. Oh, Anarat al-Shawari, yeah, Anarat al-Shawari. This is street lighting. For example, 12 a.m. 12 a.m. is 100, 100, and 100, and in 8, the street lighting is off, and until in 6 p.m. again on, and the load is constant because the number of street lighting is constant in a in these feeders, okay? The residential is 200, 200 and reach to 500 and reach 1,000 and again come back to 200. And commercial is 200 and 1,000, 1,200 and others, okay? For this load, please see the demand or load in the primary feeder is shown here. Please see. For example, to this time, we have street lighting 100, 200 for residential loads, and 200 in commercial loads. 200, and 100 will be 500 kilowatts, and others. This curve is shown the load curve for primary. Okay? And demand curve again is shown here. This curve is averaged by the delta T, and we reach to load to demand curve. No problem. I explained before this. Okay, other characteristics is the diversified demand. Diversified demand. It is the demand of the composite group as a whole of somewhat unrelated loads over a specific period of time. Here the maximum diversity demand has an impulsor. It is the maximum sum of the contribution of individual demand to diverse demand over a specific time. And the non-coincident demand, it is sum of the demand of group of loads. I explained this in other example. Demand factor, please see, demand factor is the ratio of the maximum of demand to total connected demand. Connected demand, it is the sum of continuous rating of all of the equipment connected to the systems. Do you need to explain in detail? Demand factor. Please see. If you need, I explain in detail, and not, I continue. Please comment me. Okay, please see. For example, we have one feeder. We connect here in the home, for example, in the home, refrigerators. What is translate of Arabic language in refrigerators? Mubarrid? Yeah? No? For example, cooler. Cooler. And lighting. example. For example, you have a refrigerator in the home, approximately 400 watts. Salaje, Carol. You have a salaje, and its demand is 400 kilowatt, 400 watts. And cooler, for example, hydro cooler, مبرده, yes, مبرده is 1,000 watt. And you have in home 20 lamp. Each lamp is 50 watts. إهمال إنارة in the lighting, for example, lighting in kitchen, in rooms and others. Okay. Let's see. Okay, and for example, a TV is 200 watts. Okay, we want determine demand factor for this home. Okay. If you connect a data logger here, maybe you see a load curve or demand curve here. The summation, the maximum demand measured and recorded by data logger is, for example, 2,000 watts. For drawing this load curve, you need to load curve for TV, load curve for refrigerator, load curve for cooler, load for lighting, and summation of this load curve will be these grouped load curves. Okay. For example, maximum is 2,000. For demand factor in this home, you write the maximal demand 2,000 and connected load. Connected load is the TV plus مبرده or no ثلاجه plus مبرده plus إهمال إناره or multiple and 50, 20 lamp, 50 watt, 1,000. $2,000 divided on this number will be demand factor. The maximum demand divided on total connected demand. These are total connected demands. Any question? No comment? Okay, I can end this here. I introduce other characteristic, utilization factor. Please see. For example, you have a distribution network. The capacity of this transformer, this is transformer, not better, for example, I show you this type. You have rated system capacity, for example, 300 kilowatts. It is the rated system capacity of the transformer. And the maximum demand, for example, 200. Okay, the ratio of 200 of the system demand to rated of the capacity of the, for example, transformer is a utilization factor. Okay? For example, in Iran, utilization factor in transformers is in 0.7 and 0.30. If utilization factor close to 1, the transformer has not any reserve margin, and if reach to the lowest, it is shown the placement of transformer is not in good situation. You use very big transformer in a small load. In this year, utilization factor approach to lowest number, and in heavy load the utilization factor reach to 1. Okay, no problem. Okay. In utilization factor is the can also be found for a part of the system. You can use utilization factor for generator, for transformer, for feeders and other things. We have other characteristics used or served, multiple and, for example, if you want to put the plant factor for this transformer, you use, for example, plant factor for 1 hour, for one year, for example, 22 years. Equal. Energy served by this transformer, in 22, in year 22. This is the energy served or produced for generator and served by other equipment such as transformers and others. Divided on maximum rate of transformer, for example, 300 multiple on 24. Not 24, it is hour, it is 365. It is the Mach rating multiple on time of year, and here is the actual energy served or produced. Okay, no problem. Okay, you can compute the plant factor for annually, for weekly, for daily, and many time duration. I want to introduce a very important characteristic. Please see load factor. Load factor is the ratio of average load to the peak load. Let's see. For example, this load is for Iraq. For example, in one day. If you write FLD average demand or average load to peak demand or peak load. Load factor is the average demand, peak demand or peak load. This is the load factor. Okay? Load factor is very important in planning. Please see, for example, in Iran, the lowest is in 28,000 megawatts, and this is reached to 60,000. If we want to compute the load factor for Iran, we need average demand and peak demand. If you divided average load to maximum load, you can reach to load factor. You can compute load factor for 1 day or 1 week or 1 month or yearly. You have any question? Okay. The average load occur on the system in a given period, day or month or year, is known as average load or average demand. The load factor indicates how much of the cost to the system is used to supply the load during the peak period, and the load factor is high in transmission line while it decreases in distribution network. It is important notes. Please see, it is very useful description of the load factor in some countries. I focus. Okay. Let's see. The load factor approaching to 1 is better for countries. Okay. For example, see here. The load factor for Armenia is approximately 0.5. It is very low. Is, for example, the load factor is approximately 0.7. It is low, not high. Okay. About Iraq, I have not any idea. If you have any information, please tell me.
You are
Arisa, the 0.98 is very good. It is very good. And 0.95 indicate the load. The load in your station is very flat. If your load is very flat, the load factor approaching to 1. You see, if one country, the load curve in summer, in winter, in all times is varied. For example, here it can be reached the load factor to upper 19. But in countries, the load, for example, in winter is low and summer is very high. The load factor is very low from 1, for example, 0.5, 0.6. Okay? You know? This is the other characteristic. This is the electricity prices for households in US dollar. Please see. Oh. For example, in Austria, in Europe, for megawatt hour, for kilowatt hour, you have, for comparison, this is very important, you have 0.25 cent per kilowatt hour. 0.25 cent US dollar per kilowatt. In Canada is approximately 0.1 cent. And in Denmark and Germany, Denmark is the highest is the 0.4 cent per kilowatt hour. Okay. In this year, the blue number is 20 this year and others, and many countries are shown in these figures. The price of the households. Okay. In Iran, the price is very low. It is a weak point of the electric network in Iran. The price of the electricity is very low. In other figure, the electricity price for industry. Let's see. This is the variation of electricity prices for industries in US dollar megawatt hours. Okay. Okay, if you let me, I want to continue other characteristic in next session in next week, and I think it is enough for today. And please download this slide here, and I send the reference chapter from one of references to you for using details from reference book, and also please refer to this slide for better understanding of the distribution load characteristics. Okay. If you have any comment, please let me to know. If you know, I want to goodbye, and I hope you safe, and see you again in next week, inshallah. Thank you for your consideration, for your attendance, and see you again in next week. And please, in afternoon, refer to a WhatsApp group. I send you the chapter 2 of the Conan reference book, the reference of these slides from chapter 2 from Conan reference book. I send you afternoon the reference chapters for you. Okay? Thank you for your consideration. Goodbye.
Goodbye.